Good morning. Hello, everybody. 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 Are we back? Yes, we're back. Whew. Wow. So my computer completely locked up. Couldn't shut it down. Had to hard shut it down, and it wouldn't boot. It did a 3-boot reboot. Wow. So whoever said just turn your speakers off, no, there was a problem. Like at the OS level, like something bizarre happened. There was just everything on my machine was anyway. Wow. Hi everyone. Oh, wicked. That was so good. It's not a computer, it's a Mac. Yeah, it's all because it's a Mac. Apple are out to get me. How's everyone doing? Hope you all had a great week. Wow, we just lost a whole bunch of people. Hopefully people will come back when they realize the stream is going. Yeah. Wow. Sorry, everyone. Very sorry. Oh, boy. Okay. I'm going to need like 3 coffees this morning or something stronger. If it was Windows, I'd still be down. If it was Windows, it wouldn't have even booted ever. Yeah, I've never seen this before. I've never experienced this issue before. So I don't know what it was. A bit frustrating. I wonder if I've lost all my settings for my apps that were open. Irish coffee. No, it's not Irish coffee. I wish it was. Okay, let's do a quick roll call. And then I've got some stuff to show you. And then we're going to talk about this stuff that's on my desk. No, I've not burnt my desk. I've not set my desk on fire yet. But it could happen today. It could. It's possible. No, I'm not playing with mains power. But anyway, we'll see. Okay, roll call time. And I lost heaps of the chat, obviously, because of the restart. So I'll do my best. Dave Darko, hello. Johnny, Michael, Bruce, hi. What? Bruce has got 15 terabytes free. Free of what? Hey, Rob. Hi, Adam. Peter, hello. Embedded Hobbyist, hi. David Dessa, hello. Andy Mouse, JTax. Did you get your BNE thingy 33, whatever I was working? Amory, hello. Azzy, hi. John Jones, hello. Nick Tucker, hi. Dave Hines. Rota. Stardo0815. aka Soggy Buns, hello. Braden, welcome. Christopher. Scrolly. Photo Chromax, hi. Andy Day. Francesco. Shibu. John Raymond, hello. Refresh my screen. Refresh it. What do you mean? Refresh it. Get some refreshing spray. Death Shaker, hello. Michael, hi. Stephen Ludgate, hi. You choppers. Must be a pommy thing. Choppers. Still scrolling. Graham, hello. Carsten, good morning. Jonathan Staples, hello. Oh, it jumped. Oh, now I gotta go backwards. Chris, hi. Mark, hello. What did you miss? Yeah, everyone said the Mac sucks, so it died on me. Hello, Renee. Hello, Mike. That's Mike Panter. Aaron Knox, hi. Okay, I think no, Savage Electronics, hello. X Micron. Okay, I'm just scrolling up and down now, just randomly. I feel like an idiot. Blaine, hello. Okay, cool. I think I got everyone. If not, I'll say hi later. Oh, refresh people to the old... Right, okay, yes. Refresh your browser windows. You might have to refresh your browser windows. As I said, I've never experienced that before, ever. And it was OBS did something. It was OBS, because halfway through the music countdown, I can't hear the music when it's playing for the intro. And halfway through, I could suddenly hear the music, and I knew there was a problem. I didn't know how bad it was until I spoke and started echoing. So, yeah, really weird. Really weird. Okay. So, first thing I want to do is show you this. I'm going to have to move my Mac down. No, I'm not showing you my lap. I'm showing you this. Da-da-da. Look at that. One-handed. I've got my drawer made out of aluminium extrusion. No V-wheels. All 3D printed and aluminium extrusion. And yeah, it's absolutely awesome. No knee bump. No, it doesn't touch my knees. No, it's perfect. It's 20 millimeters high because it's the 2020 extrusion. Yes, the patrons have already seen it, but the patrons haven't seen it with the rubber anti-stick surface. So it's anti-stick. It's stick. It's whatever. Anyway, yeah, I'm really happy with it. It worked out really well. This is how far it slides out. The end of it is right here. I can get the whole opening. The back extrusion is flush with the desk here now. So remember I said last week that I'm limited. I've only got just under 300 millimeters. There's a bracket through the desk. So I can only have 300 millimeters for the movement. So I only wanted something that could put all of my screwdrivers and stuff in it. Now I'll probably make a wider one on this desk because this desk doesn't have that down the middle. But this desk and my one on my left has that down the middle because they're both motorized raising desks. Am I going to add? I'm just going to move this over here. Am I going to add another around the desk? Yeah, I'm going to put. Probably on this desk over here. I'm going to do the same width, but I'm going to make it twice as long. In terms of depth, I wish they made a 30-30 extrusion. I don't want 40. 40 is too deep, but 30 would have been perfect. For this, 20 is perfect because all of my tools, like I already knew what I wanted to go in here. So I've got access to my cutters. I've got access to some tweezers, I've got my calipers, I've got my knife down here, which on this end, and I've got all the range of my different screwdrivers that I use. And it can all be open and closed with one hand. And it's just using, I'll show you. Let me just raise this up again. It's just using a custom 3D bracket that I designed and printed. So it's just doing this. There's no wheels or anything else. It's all the weight and everything is being supported by 2 clamps, one on each end, that are screwed on. And it can actually take a heap of weight. Like, I'm pushing this really hard. You can see it flexing. It can take so much weight. They actually do make 30-30. Do they? I've not seen any online. Interesting. Okay. I'm doing it wrong. Yeah, I'm doing it wrong. Now, the only thing I want to do now is on the front. I mean, you can see the edges of the side extrusion here. The extrusion at the front looks good. It's black. It all matches. I might put some, like 3D print a cap or something on here, because you can see the silver. It's black anodized extrusion, but you can see obviously that the aluminium on the sides. So I might put something in front there, but like you can hardly tell it's there. My carpet's dark, so when you're looking at it, it just looks like dark from underneath the carpet. Yeah, I know I can get 20-40, but 40 is too high. Yeah. I can start now, raise here. Yay, raise here. I love those Perigama flash cutters. Very nice design. Thank you. Yes, they are cool. They make 10, 10, 15, and 30, 30. Really? Okay. Maybe just the places I've looked. The cheap places online. Just, I've never seen them. But, interesting. Okay. No, I did file down the edges. There's no exposed edge that's going to hit me. So it won't scratch me. But I did file down the yeah. I doubt, like it's, yeah, I don't know. I don't think I'll get damaged from it. Thanks, Peter. Adam's got 15. Okay, I'll do some more research. Okay, that's fine. And the bottom's just screwed in. Again, using just T-nuts and screws held on there. And then I've got this stuff. This stuff here for the non-stick, you know, it's that plasticky stuff you put on the bottom of drawers, like utensils or tool drawers. I was looking at the EVA foam, but it was, the thinnest I could get was too thick. Oh, here we go. Thanks, Johnny. AliExpress, guys have, okay. Yeah, non-slip, not non-stick, non-slip. That's what the word I was looking for. So, yeah. And that was supposed to be electric blue, by the way. But it is not electric blue. So, that's the first thing. Very happy with that. Now, let's get straight into today's crazy idea. Well, it's not a crazy idea. And it's been done before. So, you all know about my rework hot plate that I got, right? Let me go get it. This guy. Yeah? Oops. So many of you have got something like this already. Thanks, Rota. Okay. One day I'll understand the joke. The sec joke, I don't know. So it's too high. Like it's uncomfortable to work with, right? I'm just gonna move this down. So trying to put it in a place where you can see. It's too high to work on. Like I can't, when I'm reworking, like it's normally, you know, 0402 components. I need my microscope over it. I have to lift my microscope up really high. I have to stand at this to work at it and to be able to use a microscope because there's a massive amount of heat coming off it. And it's just uncomfortable to work on. Like it's I can't rest my hands anywhere, right? Yeah, I know, Johnny, you told me it was too high, but they don't make shorter ones. This is all I could get at the time, and I needed it in a hurry back then. So I've had a few ideas about different things I could do. Like one of my ideas was to get a custom desk, cut out a section, which can be lowered. And so this could be lowered down to desk height. Hang on a sec, I'll look for the joke. Place it inside the table. Yeah, I thought about doing that. Let's talk more AI controlled file. That's what, hey, Station 240. Right, but I don't want to cut a hole in the desk. Like where I work, where I would use it, I need a normal desk here. I don't want a hole in the desk. And I don't want a removable section of the desk. I don't want to buy a new desk just for it. And I don't want to wreck my standing desk. Well, firstly, I can't because there's a bracket going right through it, right? Anyway, so, and really all I need is a warmer, right? I don't need a reflow with this thing. Like I'm not putting it on here to reflow. I don't need to get it to 300 degrees. I just want a warmer to make it easier to rework. So I got myself one of these. Yeah, I don't want to use it. I want to see if I can find a better solution, right? So I got myself one of these. Let's see if this will work now after the restart. I got myself a Creality PCB printer heat bed, 24 volts, 220 watts. So it's about 9 amps, right? Now this is bigger than what I wanted. This is for the normal size printer, but I wanted like a 100 by 100, 110 by 110, whatever, something like that. But the only ones I could get were from China, and I got this locally. I didn't want to wait 4 or 5 weeks. So what I'm thinking of doing is I'm going to do this as an experiment, right? Again, I'm not wanting to get this up to reflow temperatures. I'm wanting this to get up to, let's say, 100, 110 degrees. So the idea is that when there's a board on here, I'm still going to use my hot air gun to rework. But the problem with using hot air for reworking, because I rework panels at a time, I don't rework individual boards. Let me just move the chat over so I can see. Thanks everyone for these super chats, by the way. I really appreciate it. So I'm working on like one panel at a time. And the reason is the amount of time it takes to heat up. Like the heat dissipates out, right? Like it all gets wicked out across the whole board. And so when you're working on a cold PCB and you're, let's say, trying to rework that part over there, the amount of heat you need to get onto it to be able to rework that part, you need to put so much heat here, right, that you can shock the components and stuff. So the idea is to have a heat bed at, let's say, 110 degrees, so the PCB goes on, and then I don't, like, it's much quicker and I have to use less intense heat from the hot air station to be able to reflow a component to be able to rework it, right? 100 degrees should be fine when you touch it, but burns are part of the experience. Right, the reason I didn't want something so big is I didn't want to risk getting my hands on it to touch it. But as an experiment, what I want to do, I want to see if this will even hold up, right? If the plate will hold up, because the plate is going to have to get to, in sections, very small sections, it's going to have to get to 300 degrees. Now, what was it'll freeze your desk under it. No, this is not a peltier. That's the heater. This is it's a aluminium PCB. No, it's 24 volt only. This one. I've got to read back. I don't know what a high temp silicon mat's going to help me with. I want a heat bed. Asbestos. I don't know. Okay, I'm not sure why we're talking. Okay, anyway. Why not use a 220 volt heater? Because I don't to heat what? Okay, anyway. What am I going to connect a 220 volt heater to? Okay, guys, that's the problem. I'd have to get a some type of custom aluminium bed. I can't put a 220. Okay, let's take a step back. Okay, I'm going to try to keep calm today while everyone's telling me to do everything different. This is what I'm doing today, so you can all follow along if you want to. Telling me to do something different is not going to be helpful. So, let's get back to this. This is a PCB heater. This is an aluminium PCB. So you can see on the back here, you see the traces. This is an all-in-one heater. This is not a sheet of aluminium with a heater on it. This is the heater, right? So this whole thing heats up. The question is, how long will it last when I'm hitting it with 300 degrees from a hot air station? And so I'm just reading. And I also need to obviously support it off the bench. And no, I'm not going to stick a piece of asbestos underneath it. I'm going to, for the moment, now this is just an experiment. I'm just experimenting right now because there's a lot about this that isn't what I want as an actual concept, right? So the thing under the tape is the temp probe, for anyone wondering. Yes, except I've put my own one on. So the one it comes with, this is the one it comes with, but I don't know what it is. It's not a K-type probe, and I don't know what it is. I don't have the correct measuring tool for it. So I've unplugged this one and I've stuck one of my K-type probes in underneath, which is currently connected to a reflow master. So the idea is that I would control the heat bed. I would control this from my reflow master. It would keep it in temperature and I'd be able to monitor it, and it would also be on a timer so I wouldn't accidentally leave it on. But I need to separate this off the bench, but I want to keep it as low profile as possible because I want to put it on my desk under my microscope so I can work on it. Now the problem is, because it's DC, 24 volt DC, I can't use a regular SSR on it. Now you can get SSRs that can drive DC, but they're extremely expensive from the ones I've found. I did want to use just a regular SSR, but because there's a triac inside it, it won't switch DC, which is really unfortunate. So what I can't do, I can't do PWM on this. What I'm going to use instead for the moment, just for this experiment, is I've got a relay board. Well, it's a multi-relay board. Which means I can't fast switch it, which is going to be a bit of a problem because the reflow master is designed to use PWM to control the temperature, and I can't use PWM on these. They won't switch fast enough. So I'm going to have to kind of hack some code for that. And I've also had to add it to one of the spare pins that I've got broken out on the side to be able to control it, because I can't use my relay or my SSR connection on the reflow master because it's not a high and low. It's a switch. It's an on and an off. But that's okay. Right, I could get a decent MOSFET board, but I don't have one. So this is all I've got. Right, the idea was to experiment with this today based on what I have here. I don't have I don't, like my fan controller I can't use because it won't go up to 10 amps. I need something to go up to 10 amps. I don't have anything else here right now, so I'm going to have to use a relay. Yeah, Blaine, I'd like to use PWM, but I can't on the relay, on these relays. So for now, it's just going to be on and off. We'll see how it goes. So my plan for the time being is to use some of this Viton, which is the heat retarding or heat resistant rubber. And I'm going to just use some aluminium underneath with the Viton in between with some T-nuts. I know that some of the heat will get whipped through the screw into these. So it's a matter of measuring these to see what would happen if you give the heat bed AC. I don't think it'll work. I mean, they're just PCB traces. 3-volt 6 amp DC power adapter and an AC smart plug. Alexa, heat my board. Well, I need a 10 amp DC power supply. And yes, it's going to be Alexa, set my desk on fire. Nope! Use stainless steel screws. Why would PCB traces care if it's AC or DC? Well, I don't know if they'd heat up if they've got alternating current going to them. I don't know. No, not an early start. Normal time. Okay, cable tie. Thanks for popping in. Ceramic fibre blanket underneath. Right, but I don't have a ceramic fibre blanket here. I can only work with what I have here right now. So I need a knife, and I need a ruler, and I need my T-nuts and screws. And we're going to have a bit of an experiment with this. Now, ultimately, whatever I come up with, I want to be able to also mount a fan underneath. So, I can cool the plate down when it's done, because the issue with using this as a heater, as a preheater, is that it holds its temperature for a really long time. If I set this to 100 degrees and then disconnect the power, it's going to sit above 80 degrees for like 15-20 minutes. So, don't you have a fire blanket in my kitchen? Nope. Hey, Intimate Tech. Right, I don't have a silicon mat. I don't have anything else here. I'm going to use what I've got right now. And I don't want this sitting on a silicon mat. I need this raised, as I said, because I need a fan underneath it. So, first thing I'm going to do is, I might need to get a drill as well. I'm going to have to cut some little squares out of this to sit between the cool. I don't think I've got any stainless steel screws here. I just need 4 squares just to sit this off the extrusion to give it a bit of a thermal barrier. Now, going forward, I could absolutely get a custom hot plate machined, and I could get an AC heater pads that can go up to 400 degrees. One's designed for furnaces, and I can control it via the SSR again, no problem. But I don't have any of those things here, and I'm not going to invest in getting all of those things until I've worked out that it's going to work the way I want it to. Not will this work the way I want, but will the setup be comfortable for me to work with, and will it allow me to rework better than using the other thing or any other methods I've got right now. So for $40 and everything else I already have here, this is a very cheap way for me to experiment with it. I can't find listed anywhere, Dave, what the actual specs of this is, how high it'll go. I would assume that it should easily, I mean, it's an aluminium PCB, right? So it should be able to go much higher than a 3D print bed would ever need to go. But how long it can sustain that for, I don't know. This is a proof of concept, not about whether this will heat up or not. But for instance, if this is sitting this high, right? So this is sitting this high. That's still too high for me to work. You know, I can only, well, it's my left hand, because I'm hot airing with my right hand, right? So I'm using my tweezers with my left hand, so grab my tweezers, right? So already I've got a problem where I can't reach over, yeah? Unless I burn my fingers, burn my hand. So, you know, I'm going to need some type of, right, I don't have anything else. I'm going to need some type of edge around here that I can rest on that's part of the unit, right? That I can get over so I can reach. And I'm going to need to be able to move the board around, right, on the panel like this to be able to get to it. So I'm going to need some heat retarding here that's going to have to probably overlap the heat bed. There's a lot of stuff I need to work out. Like when I'm reworking panels, right, I could have a pile of 50 or 100 panels I need to burn through. I'm not looking for a, hey, this is something I use for 5 minutes once every 2 weeks. I'm looking for something that I can use as a workhorse, right? Where I can sit comfortably for hours at a time reworking. Hey, Colin. Right? So it's not just about, can I heat this up? I know this will work as a heat bed. I'm pretty confident that I'm not going to do too much damage to it by pulsing 300 degrees at it in very small areas for short bursts, right? One issue is the amount of heat it loses to space due to its relatively high surface area. But that's okay, because I only want this as a warmer. If my PCB is sitting here at 80 degrees, my PCB is much easier to rework if my starting temperature is 80 degrees than if my starting temperature was 0 degrees, right? Panels to burn through. Yeah, that's funny. Yeah. Okay, I need a drill. I need my drill. By the way, it was 5 degrees in my office this morning when I walked in. Okay, I'm gonna, this will be a bit silly, but I'm gonna drill on my desk. Here's a bit of wood. Where did I just put that pile? I'm gonna, I need to drill a hole through the middle. I'm gonna do a pilot hole to start with. Okay. What's $300 delivery cost? No, I didn't say 0 degrees. I said 5 degrees. Who said 0? Okay. Big bit. Oh, it wasn't very straight. And I did want to not get that all over my desk, but I just got it all over my desk. That's annoying. Normally I do this in my garage. But you know, it's a stream. Just want to clean this off. Yeah, good one, Sion. Nothing like a bit of rubber everywhere. Drilled rubber. 5.8 degrees here at the moment. Oh, ouch, Fred. Hey Eric, how you doing? Okay. Wow. That's messy. Okay, so now just need some T-nuts. Oh, that really stinks, that rubber. Okay, I need... Now, I don't know if I've got screws long enough, so I guess we're about to find out. The only countersunk screws I've got are these, and I think they might be too short. But maybe not, we'll see. I might have to put the... yeah, I'm going to have to put the T-nut in there already, I think. Let's just see if we can get one on. Let's see if... No, it fits. Okay, good. Wow. I don't have a lot. Look at that. One hand opens the drawer. Gets out the tool. Wicked. Okay, good. Yep, that fits. Excellent. Okay. I wish I had so much space. I don't even have a place for a 3D printer. Yes, I'm very lucky with the amount of space I have. I know. As they say, it doesn't matter how much space you've got, you end up using it all and making a mess anyway. Oh, come on. Thank you. Okay, so as I said, I know heat's going to transfer on the screws, but this is better than nothing, and the Patron here will hopefully take most of the heat transfer away, as much as possible anyway. And if this works, then I'll find something. You know, if this is comfortable enough, I'll find a better solution. It's not a great angle to do this on under my camera. Sorry. Stay in. Oh, I took out too many T-nuts. That's okay. Oh, and it came out. Okay. So I've avoided using any type of extrusion in my projects since I started as a maker, and now I've used it in 2 projects in 1 week. Yay. It's actually pretty cool. Okay. So now this is elevated off the bench. You regret doing it that way. They'll act as massive heat. We just spoke about that, but they won't be massive heat sinks because they've got Viton, which is completely heat retarded, in between. So the only heat transfer is really going to happen via these screws, which shouldn't be much right now. So I'm not going to regret it. It's the only option I have right now. Okay, put that away. Coffee time. This is not my permanent solution, as I said. This is just for now. Hey, Ian. So, I probably want to move this over to my... No? I wonder if we can do it here. There's quite a few things I need to do first. So, I'm going to be using one of the power supplies that was from the Charm High feeders. So it's quite loud, but that's okay. I need to, right now it's just wired up directly to here. I just wanted to make sure that the heat bed worked before the stream, because well, that's what we can do. We can actually, we can heat up the heat bed and measure how hot the aluminium's getting. We could do that. Does that even matter? Do we need to know that? I don't know if we need to know that right now. Use wood 1 by 1. Yeah, I don't think wood's better than what I'm using right now. Once again, there's Viton in between. For those that don't know what Viton is, it can take up to 270 degrees. It completely blocks heat transfer. More like how long it takes to use the... Well, I'm going to use the reflow master. Anyway, okay, so we need to cut some cables up. So I don't have, so yeah, I've been putting everything away, cleaning up, and now I reckon yeah, it's fine. Okay, I'm just going to unscrew this. So the cable on the printer heat bed is obviously not very long. I don't have any high gauge or low gauge wire, believe it or not, which is pretty crazy. So I'm going to cut open a power supply. I'm going to turn my heater back on. It's getting cold in here again. Did I miss the fire? No fire yet. There could be. So I've got stacks of power cables, right? I mean, I'm just going to cut one. Cut one, strip it out for the wires so I can lengthen the wires. One end. Two. They can go in the bin. Not going to use those. Knife. Are they fused? Oh, what fused? I just need some wire that's going to be able to handle 10 amps. I really don't have... I don't like normally work with anything that requires that. Okay. I'm probably going to have to pull some out and separate them. the bed is a big fuse. Okay, so I'm gonna also need some connectors. Got a whole bunch of these that I can connect together. So, bun in your hair, what does that mean? Who's got a bun in my... What? Yeah, this is mains. This is just a like a computer power supply. Whatever the... What's the name of the standard? Whatever it is. I don't know. Should probably ferrule it, but anyway. What colours am I going to use? Doesn't really matter in this case. Love this thing. Really good. I can get those wires out of the way. Like that. Beautiful. Suicide cords. Why are they called suicide cords? I'm trying to clean up as I go. Get some rules. Okay. Black and red. Realize already. Main issue is the watts needed. 24 volts and 10 amps is only 240 watts. Once again, I'm using the plate as a warmer, and as I apply hot air to the plate, that's going to increase the heat of the temperature of the plate, which is fine. It's a warmer. That's it. Right, vaccine. You're gonna fly all the way to the UK. You can't fly to the UK to get the vaccine. I can get now as well. I'm gonna organise to go get next week. Okay. Does anyone have any preference on colours? No, I'm just gonna use brown for black. And I'm going to use blue. It's going to be red. Brown for red, blue for black. Doesn't really matter. These are just pass through. As long as I label, as long as each one is the correct colour at the end, I don't really care. This is not mains wiring. It's just DC. Okay. And this end, it's just so I can get the power supply off the desk when I'm working, when I'm trying this thing. That's all. Will the DC like the AC cable? I didn't ask it. I should ask. It's not very talkative though, the DC. Okay, so that's that. Okay, so we're going to want anyone seen Mark's tweezers? Maybe they're in my drawer. Maybe not. Okay. So, ground. Ground is going to go to ground with one of these. So these just cut off, don't they? I've never actually used one of these before. I guess they do. Assuming that this hole is big enough to get it in. No, it's not. Interesting. How'd that move out? I don't know if I'll be able to squeeze these in, these ones. I might need bigger ones. I don't know if I've got bigger ones. It goes on that side. Screwdriver. Wago. Yeah, I don't have any. Actually, I do have some Wagos somewhere. Okay, so ground to ground. Now I've got to go to the relay. And where it's going to get a bit so these relays are designed to be low, active low, which is a bit of a pain. So I've got this by default as on, always on. I don't know if I'm going to get these rules and damn. Might have to squish the ends. Yes, good. Okay. Got to stay awake for 30 minutes. Why? What's 30 minutes? What's happening in 30 minutes? So does anyone know why the SN15 launch was delayed? Why they shifted it? If I didn't watch, I can't keep an eye if unexpected ways doing things wrong. That's true, Mark. You gotta stay here so you can tell me if I'm doing things wrong. Due to medication? What? It was, yeah, I knew it was scrubbed, but yeah, no reason was given. I couldn't find a reason why. Okay, so we have relay, power. So we've got ground, so I should be able to just put this into here. Get this one out of the way. Should just cut them off. Okay. winds. High altitude windows. Winds. Yeah, okay. I got it. I saw you corrected to winds, but that's pretty funny. High altitude windows. Okay, so we've got power supply. We've got 24 volts from here going to the relay, going to the heat bed, and then the ground path or earth path is going all the way back through to the power supply. So, and we have a nice long cable, so I can put this on the floor. Now, I was going to connect this to the AL, she who should remain nameless, for this today, but I decided instead to connect it to a power board with a switch. So if something goes bad, I can quickly switch it off rather than relying on her to turn it off for me. So, I'm not turning the power supply on yet, but it's quite noisy, as I said. Okay, so now I'm going to move the relay over move all this over to this side. I don't need some of these things anymore. Get off. Get off. Right, I was just testing with a fan yesterday to make sure that I could use the reflow master. I didn't want to stuff around for 2 hours trying to get the reflow master working. Okay, so let's just get the relay on screen as well, and maybe the reflow master as well, somewhere. Now, I'm not quite sure how we're going to do this yet, and probably get some blue tack to hold this cable out the way. Do I have a Variac? No. So the question is, so it's not powered right now, and this is obviously not plugged in, which is stupid. Get a USB cable to lower the voltage to the... No, I don't. So the issue is, as soon as I power this, you see what it does? Because as soon as once I plug this in, even though it's not turned on, this pin is grounded, like it's pulled low. By default, the I/O is low, which means it's turned this on. Right? Which is the problem. So this is not my ideal setup. Hey, John. At least switch both poles. What? What are we talking about? The thermal dependent change in resistance in most heating element. So I'm just reading. What are the DC ratings for those relay contacts? These are 24 volt, 10 amps. And this is 24 volt, needs about 9 amps. Anyway, when I turn this on, as you can see, it turns this off. Turns it on. Now, because this is set to normally on, having this on makes this off. Right? So this is currently in its... This is on, which means the relay's on, which means the normally on is now off. Use the other set to turn behavior around. No, I don't want to turn the behavior around. I want this behavior because by default this gets pulled on. I can't change the behavior on this side, right? So this is the correct wiring for this case right now. As I mentioned, this is not really this is not my ideal setup. My ideal setup would be a solid state system, not a relay, and eventually possibly an AC heater solution, not a DC one. But for now, this is fine. So I should be able to, as I said, it's not powered, but as you'll see here, if I now tell it to go into bake and start, it turns this off, which means it's heating, because this will then turn on. And when I abort it, this turns on, which means the relay should turn off. Or as in, yeah, right? Use the second relay via another output. No, I don't need it. This is fine. This is perfectly fine. So, I've got the thermocouple over here connected to the bottom of the to the PCB. I've also got another thermocouple here on my DMM, which I want to measure the aluminium. So what I'm going to do is just get some Kapton tape, and I'm going to stick it to the aluminium, to the side of the aluminium. I made a desk burner. Yep. What you're making, a reflow plate. Not a reflow plate, a rework plate. I don't want to reflow boards on it. Well, I don't want to reflow a whole board on it. I want to use it for reworking. So it's going to be a warmer. But I want it to, it needs to be low profile. So I'm just got my thermocouple here. I'm just going to use some Kapton and stick it to the aluminium on the side here. Silly, probably want to do it this way. Just near where the screw is, so I can measure the temperature of it. Okay, so this thinks the hot plate right now is 19 degrees, which I don't know if that's true or not. And if I put it on temperature, right, it thinks the aluminium is 19 degrees, which is good. So I wonder if my hot air will reach. What's this set to? I don't know. I've got my hot air gun. You might just see here, I'm just going to hit the plate with my hot air gun. Set to 390 degrees. So we should see the temperature go up really slowly if there's any heat transfer. Yeah, that's not really good. I can't really get it. My hand raised the temp, it wouldn't be much. Yeah, I can't get this close enough. Wow. Oh, 21. Yeah, we're at 20 now on the DMM. Anyway, okay, good. It's moving. So, yeah, didn't get a lot of heat transfer. Shall I turn the power supply on? I'm trying to think where I can get this in view that you can see it. There we go. We can see all that. T minus 120 seconds till what? What's happening in 120 seconds? Okay, I'm going to turn the power supply on. Cross your fingers. Okay, power supply is on. Let's move this over so they're not touching. Get the iron out from the closed room. No, thanks. Okay, here we go. Interesting. So the temperature's going up. So this is on, even though that should be normally open. So what's going on there? What have I done? Why didn't... It's not switching. Just turn that off. So why is this not switching? Oh, because my ground came out. Okay, that's switched. Right. Right, I pulled the cable out. Hey David, how are you, mate? Okay. At 42 degrees, oh, that's, I need more, I need to move this over. Here we go. So at 42 degrees, the aluminium's at 23 degrees. Let's try that again, shall we? So this should be off. Okay, I've turned the power supply back on. Power supply's on. This should not be getting hotter. Right, it's going down, as you can see, which is correct. And don't forget, I can add more of this stuff, stack it higher if I need to. I don't want to go too high. 80 to 100 degrees would be ideal. Right, so here we go again. I'm just going to use bake. So it should... So this might think already thinks it's too high. So that's not going to switch it on. I'm going to start a reflow. I won't let it go all the way. Okay, there we go. You hear the fan kick in. And that's turned off. So it obviously can't ramp fast enough for a reflow, but that's fine. Right now I just want to see how hot the aluminium gets. Oh, and by the way, my my RGB LED lights are doing crazy shit. So it just went red, and no, it's not fire. Hey, Groovjet. Okay, I mean that's nice and warm, and obviously the edges are not as warm as the center, but so that's 70, and we're at 30 degrees in the aluminium, right next to the screws. Yeah, the red effect looks really cool, but that's not intended. I run my bed on my Prusa at 110 for PETG. So this is really struggling to get up to 80. You can see it's slightly curving off. Temp is just cut off. What? Oh, the label might be in the way. So 87 degrees, it's about 36 degrees on the aluminium. 37. The DMM's cut off. Okay, I'm going to stop it there. I don't want to go above 90. And I'm curious to see how long it retains the heat for. And whether this will keep going up. Yeah, a little bit. For switching a high current DC, the relay needs to have magnetic blowout for the contacts. I don't know what that means. I've never used relays before. Like, this is the first time I've had a need for a DC relay. And as I said, I'd rather be using an SSR. Have I got anything to reflow to give it a go? I need to move it. I'm not reflowing here. I'm just warming here. Right, none of my paste will reflow at that temperature. I need to use it's for my hot air gun. So this will have to get moved over to here so my hot air gun can reach. But could we give it a go? I mean, yeah, I guess I could move it. Or when it cools down a little bit. I'm not moving it just yet. Don't I have a FET? No, I don't have a FET. I said that before. If I had a high-powered FET, I would be using that. I'm using what I have here right now. Do you have thermal imaging? I don't have any thermal imaging, no. I don't know how heat distribution is on it. Yeah, I can go get some oven gloves. Still, that's still a little bit too hot still. What I've also got, let me get some oven gloves, wait a sec. Okay, I don't want to tell you what I just found when I walked inside the house. Whoops, I just stood on the cable. Okay, so, how are these? Except I have to move it all. This is, how am I going to do this? Okay. Oh, knocked it. Knocked the power cable. I'm just going to turn the power supply off. Okay. Let's try that again. Will that reach? Might not reach. Okay. Trying to think what angle can I get. Move the cable. Um, okay, let me just switch. Okay, you guys can see here now, hopefully. Yep. Okay. So, will that reach? That'll reach. That's the one way around. So I just got a bit of spaghetti right now, which I need to untangle. Should I just make that worse? I think I just did. Okay. DMM. Hot plate. Get this around the other side if I can. Okay, so here's a hot plate. Can't see the chat. Just moving the chat over. Yeah, I got a bunch of cork mats. Yaz bought me some more of these ones. That's my DMM saying, turn it off, the battery. She bought me a whole bunch of these. So I've got, see, I already scratched it. I've actually got cork mats that I can put underneath it. The issue is it's going to raise the height of it, which I don't really want to be doing right now. The whole point of this is to have it low profile. More cork mats, yay! I mean, this is too high to work on, but now I don't have the microscope camera plugged in, so I'm not going to be able to show you the view through the microscope because my little adapter died, which is fantastic. Okay. It's upside down. Add a silicone or tape to the edges. To the edges of what? I just want to, I mean, we're not going to be able to, like, again, the idea is to use this, I mean, I can already feel, like, this PCB is warm, right, because the heat's transferring from it, which is what I need. So if I put this on bake, and I set it to, I don't know, 80 degrees for 20 minutes. Oh, power supply's not on. And it's nice and loud. DC issues why RC relay rating, you should smell a rat when the AC and DC current ratings are the same. What do you mean smell a rat? What? So interesting. So my baking code might not be set up properly because it's, well, it's going, it's turning on and off, but it's must have the range set too low. Another type of preheater, just 80 degrees, but open a new window. Let's have a look. Oh, that's interesting. I've not seen one of these before. Hold on, let me just switch. So yeah, Johnny just sent this through. So what does it do? It heats up the silicon. The mat does it. The problem is I need to apply 300 degrees heat to it. So I got to start. I just have to reflash. Start it again. Start. Okay, off it goes. Yeah, I know it's designed for delaminating the screens. It's a clever idea though. I've not seen anything like it before. Because I can't PWM this, I have to just set a threshold, right? And I don't know what the threshold needs to be. I'm guessing at the moment. Because it takes a long time to cool, then I don't want to be ramping it all the way up to getting close, because it's going to way overshoot. Like I want it to get it within 80% and try to keep it there, because that's going to keep it going, if that makes sense. Okay, so this is currently at 50 degrees. And it's trying to get to 80, but it's probably going to cut off at about 55 or 60, which is fine. But it's about then getting the right, 57, 58. See, it's turned off, but it's still rising. I know you can't see the screen, sorry. Right. $59. So probably need to give it a little bit more. This one looks like what Sion is going for. Which one's this one? Yeah, I've seen these ones, but these also won't go hot enough. And they're not designed to take the extra heat from a hot air gun. That's the problem. Like the PCB, there are pockets of the PCB that's going to get really hot. So that's the problem with something like this. And then the other rear workstations that you can get are just too tall. You know, this type, which is shorter than what I've got, it's still too tall and too hard to work with. And then it's still not designed to go as high as I need. And then you got this, yeah, these types here. I mean, look at how tall these are. And you got these type of rear workstations here. They're just not the right thing. Okay, 60. This is getting to 65 before it switches off. So it's going to come down to like taking my hot air gun, right, how quickly, if this is sitting warming it, how quickly can I get components reflowing, right? So I'm pumping 390 degrees right now through the hot air gun. But the distance from here to here, right, is already dropping it considerably. My tweezers. Ugh. Okay. So I'm just going to move over to the side. Hey Shaq, 3 AM, just woke up. Crazy. Yeah, so this is still, that's not hot enough. Okay, just then. I just hit reflow just then. So I can move a component. It only thinks the actual hot plate is at 63 degrees. So this is not getting close enough. So I need my max temp to be much higher. You know, if I have to, the idea is that I should only have to apply the hot air gun for, you know, 5 to 10 seconds on an area to get it hot enough to be able to reflow it, to be able to like tweak apart. If I have to sit there for 15, 20 seconds, that's not much better than what I had already if I just did it directly on the mat. So it's about, I need to find out what, well, that's pushing it hard now. I need to find out what the ideal temperature is for the heat bed to be able to reflow quickly, if that makes sense. Yeah. Like right now my target's 100 degrees. It was 80 before, it's up to 78 now. 79, so it's 15 degrees higher. Okay, it just switched then at 80. Okay, so let's see how long it takes for me to... No, I don't want to set it to 200 degrees. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 seconds. 12 seconds to be able to tweak that part. That's not too bad. And I'm not really going to burn myself. I mean, that, okay, it's hot. But unless I really rest my hand on it, take the bottom off an iron and use that. I don't have a spare iron to take the bottom off. Yeah, and that won't, yeah. I mean, this is working as intended, but I've got to get the right balance for it. Okay, turn it off. Turn it off. I'm gonna let that cool down. Okay, so it's working. It's just, like my target's 100, it's stopping around 80 because my algorithm isn't right, because I've only got an on and an off, right? Here's a silicon heating mat that's good for 450 degrees. Sure. So again, as I said, well, yeah, already said that I can get AC heating mats that'll do whatever degrees I need. That's fine, but that's got to be attached to something, right? That has to attach to a hot plate or something, and then has to be protected underneath and whatever. Like, I know that I can buy stuff to make something different to this. That wasn't the aim today. The aim today was, can I get this working? Would this be usable? I mean, this is usable as it is right now. I could tweak the algorithm more. Like right now, it seems to cut off about 20 degrees away from where it wants to go. I could work right on that. Yeah, I probably don't want to work on that. I want to work on a flat surface that I can move something around on. Like, I need to be able to move and rotate my board around as I'm working. Yeah. So, but like RS components, I've already found stacks of different heaters. Yeah. That match to an aluminium plate. Right, except I don't have an aluminium plate. Right, and I'd need an aluminium plate that's designed that I can also mount a fan that can also sit on feet. Right? Like, again, I'm not looking for a project. I'm not trying to solve the ultimate thing. I just want something quick and dirty that I can, help speed up my reworking. I mean, this right now with a plate that was half the size, or not half the size, 120 by 120, right? Like 120 by 120. What is actually that? Right, this is 235 by 235, right? Like at 120 by 120 or 150 by 150 would be an ideal size plate to work from. It'd be much smaller. Get those hot plates for chemistry labs. Sure. But as I said, I need a mounting solution for it. It needs to be portable. It needs to be as low profile as possible. Maybe I can just put this directly onto the cork and not have the aluminium at the bottom, and that'll bring it right down. And if I did that, maybe I can then rest my hand on the cork while I'm working. I could probably get a large cork mat instead of these round ones. Get a square, large cork mat to work from, and maybe that's a better way to go. The issue is going to be cooling it down and getting it off the bench. It will never get that. How? What? There's an iron one. If you can get the heat you need at low voltages, preferred over mains powered heat mat. Yeah, the problem is if I'm going DC, I can't PWM, right? PWM will allow me to get much closer to the target temperature I want rather than guessing. Any rock wall. I don't know what rock wall is, but I can look that up. Look, there's lots of different options. Like I've got a place I can get Teflon from. I can get like a Teflon block to sit this on, right? Teflon will go up to, I think, 270 degrees or whatever. I can't PWM a relay. I know I can PWM DC. I can't PWM these relays. So I'd have to get a different solution, like a high-powered MOSFET or whatever. Yep. I understand all that. I could go and buy a whole bunch of parts and build something else. I get that. The question is, do I need to? Like, can I just use this? Like, it looks like I can just use this for now. Do I have wires everywhere? Sure. Would I want to neaten it up? Sure. Is the wiring on the Reflow Master ideal for this to drive a relay? No. Could it drive the MOSFET? Absolutely. So maybe I'll buy a ready-made high-powered MOSFET switching board. Maybe I can make one. I don't have any MOSFETs here. I'd have to source some MOSFETs. You know what I mean? Like that could be a fun project, I guess. The DC solid state relays are really expensive, or the ones I've seen anyway. DC solid state relay. No, actually that's not too bad. Solid state relay, 332 volt, right? 3 amps. Yeah, no. That's the problem. Finding something that can do a high 16 amp solid state relay 0 cross. No, I need a DC. A 20 amp MOSFET should be enough, right? Well, yes. Although I need more than just a MOSFET, but yes. Operating voltage, DC series, right? Only 3 amps. Solid state relays. Let's see if we can find. Don't we test how hot it can get if we just powered constantly? Do we want to see how hot it can get? Does anyone want to see how hot it can get? Hey, Mr. Bonds. No, I could probably just keep pushing my cutoff point in my software just higher and higher. It's just experimental. Right, everyone wants to see how hot it can get. Okay, just before that, I just want to see if I can load current. 10 amps. I'm curious to see. I didn't look at element 14 before. Show results. Yeah, see, $50. Wait, hang on. No, operating. Switching mode. DC. $10 amp, 5 volt, 200 volt, V, right. Yeah, $105. Oh, what's this one? That's AC. Yeah, I mean, these are really expensive. For something that's 10 amps for DC, it's quite expensive. Anyway, okay. We want to see how hot it can get, do we? Okay. What I can do is rewire it. Let me just switch. I'm not going to move it back though, okay? I'm just going to... I'm going to move it to always... always off, which is going to make it switch on. What I should do first is unplug the power. So this way I can leave the reflow master in the menu and I can just let it sit there and it'll just be on. And we can see how the temperature goes up to. Within reason. Oh, get in. Okay. Okay. So this should now this should turn on, take this off. So that's still quite warm. I'm trying to think, how can I... Let me... Moving my camera, everyone. Don't get sick. Don't get sick. I'm going to see if I can show you the reflow master. Why can't I bend that down? Sorry about the moving camera. How can I show you the screen easily? What can this sit on? I need something for it to sit on. How about a... Look at that. Great. Maybe. Okay, I know it's out of focus. I'll get it focused for you. How's that? Okay, I'm turning it on. I'm gonna move my microscope out of the way. One of those small header project, you get 4 channels if one goes pop. Yeah. I've got a dual one as well over there. Super sharp focus. Yeah, won't stay that way. Okay, lots of people sending me links. What are these links for? 3D printer heating control MOS set for heat bed extruder MOS. $15 from China. Okay, well that's going up. Let's quickly switch to here. So Bruce sent this. Yeah, so something like this is what I want. Yep. Okay. 62 degrees. I don't have a thermal camera, no. I've always wanted to get one, but I don't want a cheap one that doesn't... Like, I want one that actually does fairly high res and can actually give me proper readings, and they're really expensive, so... Wow, Azzy. Really? Sharpest focus? And that's my webcam, that's because it's close. I should go get a coffee and come back. Not. Yeah, the flows are really nice, but they're expensive. Is this, yeah, the degrees Celsius, 83 C. $36 for a thermal camera. Wouldn't be very good. Unfortunately, there's no coffee left. It's empty. You'll keep an eye on it for me. Yeah, can someone just stick their hand in and reach out and turn it off if there's a problem? Oh, a DC switch. Right. Okay. The flare one sucks. Really? Yeah, 8x8's not... I need something much higher resolution than that. Like, if I'm going to get a thermal camera and actually use one properly. Anyway, C should be in caps with the degrees. Nah. I'm okay with this. Thanks, though. Someone's going to hack my home power. We're at 100 degrees. oil and egg. Just smelling, if I can. I'm not gonna get it. I'm not gonna let it go above 110, folks. Sorry. Just in case. The thermocouple can go up to 300. Hey, Brian. 110, folks. I'm going to turn it off. I'm not that stupid. 110's fine. I can smell something. It's not burning, but I can smell. I don't know. It could be the Capton. Could be. I don't know. Whatever it is. I don't have I didn't have that turned on. Aluminium underneath it was at. It was at 50. It's right now. It's at 55 degrees. The smell of success. I don't know about that. Brian just released a new video. Yeah. Did he, Johnny? Really? Yeah. I'm happy. I'm happy to just leave it there. Okay. So, I guess the question comes down to, yeah, can I... Yeah, switch back. Not that you can see now. Like, could it just sit directly on the cork? Like, without the aluminium? Probably not. Probably not. Wow, that's hot through the, even through these things it gets quite hot. Miracles do happen. Oh, about releasing a video. Yeah, John McRae also released one about doing over the air with Rainmaker, I believe. Where was that link? Yeah. Oh, James. No worries, mate. Have a good sleep. Hope you're doing well. Yep, there you go. That's John McRae's link. I just posted that, and then did Brian release a video? Did he? Wow, he did too. I'm sure you're all subscribed to Brian's channel. There's Brian's link. 85 degree, it was 3 to 4 up to 90s. By mid 90s, you're looking at 5 to 6 seconds, and almost over 6 seconds per degree between. Yeah, it's definitely slowing down. Like the reflow curve was bending when it was reflowing off Reflow Master. But again, I'm only looking at. I mean, if I can get this thing to 85 degrees, I reckon 85 degrees would be the sweet spot where I could hot air a part in 10 seconds. I could fix a part, the first part, in 10 seconds, right? Because I'm applying heat from the heat gun. And so I'm already transferring heat to the PCB, so the next part might only be 8 seconds. If that makes sense? Like right now, my first part could take 35, 40 seconds before I can get the area hot enough to rework a part without shocking all the rest of the components around it, right? So this is okay. So long as it's comfortable for me to work with. Just a 90 degree NC temp switch. No, they're not rated for 10 amps usually. I think Chris also posted a link to, what's this? Automation Direct. What is this one? Okay, automation, solid state relay, panel mount, finger safe, puck, 3 to 32 VTC in, MOSFET 12 amp contact rating, 3 to 200 VTC load voltage, $18.50. Okay. Wow, that's the cheapest one I've seen. Never heard of these guys. Oh, right. They're going to be in America, right? Don't tell me that's in America. And it's their own brand. Yeah, okay. Well, let's see if I can find this somewhere else. Oh, direct automationdirect.com, direct automation.com.au. Okay. And here's an Australian website. In Queensland. Okay. $38. Looks good. I'm going to add one to my cart. And I'll probably grab one. Because then I can just use, yeah, a DC solution, whatever it is. Yeah, this is good. Thank you. Thanks, Chris. Okay, so it means I can get rid of the relay, I can use this, and I can go back to use my standard reflow master to do it. I don't have to hack any code to do it. I can just connect this to the SSR connection on my reflow master and put it in bake mode. And then it's just going to do PWM all the way up to the right spot. Now, the other thing I was thinking of doing for this was to, like right now I'm using that power supply, which is loud and noisy, is getting just an ATX power supply. So if I get an ATX power supply and I can run 24 volts for the, assuming that they go high enough, if I get a high enough one anyway, so I can run the hot plate off the 24 volts, I can run a 12 volt large PC fan underneath it to cool it, assuming that I'm not going to melt the fan, and I can then get 5 volts off it to power the reflow master and do it all in one power supply. Yeah, I think there's MOSFETs inside it. Can't you get 24 volts out of an ATX power supply? Okay. Okay, I didn't realize. Right. I can get heat beds that are only 12 volts, but they're not going to get to temperature quickly. That's the only problem with them. And a minus 12 volt rail as well. Okay, I didn't realize. I thought they were 24. It's been a long time since I've built a PC. A very, very long time. So, okay, well that makes sense. Cool. And they're pretty low current? Yeah, I don't know if they're rated for 10 amps or not. Look, I mean, I can use this thing. It's loud. You could hear how loud it was when it ramps up. I could also get myself a, you know, a quieter, like Meanwell one. But again, it's not worth me spending a lot of money on this right now. And my other option is I was looking at getting the Prusa Mini heat bed. and using that instead because it's much smaller. I think that's 185. But I've not been able to find a PCB 3D printer heat bed. Like, the problem is finding small ones. So yeah, I remember I saw this one. So it's a 12 volt one. Like, I can't find anything that's under 200 by 200 at 24 volts. That's the problem. Yeah, there's no point using two ATX power supplies. I've already got a 24 volt supply here. Try silicon 3D printer heat bed. Oh, here we go. 100 by 100. But what voltage is it? Oops, I didn't realize I was on the wrong screen. Sorry. 12 volt, 24 volt, dual-sided mini heat bed. But is it aluminium? I don't think it's aluminium. No, it's not aluminium. Oh, maybe it is. Right, it's got heating elements on both sides. 100 by 100, 2mm PCB, PCB material, but that looks like it's aluminium on the edge. Because a round's not going to help me. I need it square. Like, my PCBs are square, so like round means that where I have to position it is going to be I have to position it in the center. See, it doesn't say enough about what this is. I mean, it's $10, but I don't want to wait. Yeah, it doesn't say that it's aluminium, but, you know, material, PCB. Here's one 150 by 150. There's aluminium. $24 volts. Oh, right. The 24 volts one's 180 by 180. Make more round PCB projects. Sure. This is the same one again, but a different supplier. Maybe it'll have a different description. Yeah, fiberglass. Not aluminium. I mean, I spent ages going through trying to find something till eventually I just bought something locally for now, just to try it out. Yeah. Probably could do a Peltier the size you want, just a high temp version. Suspect. Yeah, I mean, I would go with the Kinovo AC silicon. Okay, I don't know. No idea what that is, but right. It's again like it's overkill for what I need. Like I'm not reflowing with it. Was that 100mm aluminium bed on Amazon? Do you have a link, Jonathan? Amazon.ca. Where's .ca? Well, that's that same other one. Yeah, why is Eric fuming? What's going on, Eric? Why is Eric weeping? Catch you later, Carsten. Then why are you weeping? What's going on? Yeah, I'm gonna stop looking. Aluminium heated bed, 24-volt power supply, 300 bed, safe, reliable. Okay. See, that looks the same. That says aluminium, looks the same as the other one, but that is not. Look at the sides of it. That's fiberglass. That is not aluminium. The picture's not aluminium. That's fiberglass. Well, looks like fiberglass. AliExpress. Okay, yeah, lots of options. Anyway, okay. I'm going to use this today to rework. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 panels. 10 panels I need to rework. Most of them have like only 1 or 2 components on the panel that I need to actually tweak. So it's not like I needed this for that, but it's a good opportunity. Aluminium. So I'll go through all these panels with this today, see how it goes. As I said, I need to like work out an armrest for it now from a height point of view. So what I can do is, now that not that you can really see, but maybe I can stick my, now that it's cooled down a bit, I wonder if I can get it all on the one, okay, I can get it on the one mat, and I can, here we go, oh, you can't see, camera moving folks, camera moving, so if it's sitting here, and I can use this heatsink to rest on, like this, that could work for today anyway, and see how I go. I think that's a good idea for today. My UM2 heat bed goes well above 100 degrees. C and super quick seems to be someone bang good. What's a UM2 heat bed? Oh, right. Ultimaker 2 heat bed. Right, but that's big though, isn't it? Like, aren't these large? Does it take me to robot dig? Oh. What size is it? Yeah, it's too big. I want small. Yeah, I want smaller. I've already got a solution for big. That's fine. Okay. I'm gonna use this as is for now, for today. I'll let you all know how it goes. And hopefully I can just knock through all of these panels today, because I'm restocking, because I'm out. I got bought out of all my parts, all my components. All my components. Try again. Got bought out of all of my boards. So Tiny Picos, Tiny Pico USB-C, Feather S2, and Tiny S2s. And so I've been building the last few days. So I've restocked my Micro B Tiny Picos yesterday, and did half my Tiny S2s. I've still got half on there. And then I've got USB-Cs, which I need to do, and more reflow masters, and that's my last panel. This could be my last panel of Feather S2s ever, folks. Plus what I have in stock, what I built the other day. Could be my last one. Woo! This actually doesn't need rework. I just haven't pulled it apart yet to clean it. So I'm going to start holding on to components in preparation for some S3 boards, if I ever get S3 silicon, which would be great if I ever get it. So yeah, okay, I'm going to call it. I'm going to get reworking, and then later on today, hopefully once I'm done, I'm going to build myself another drawer. Can't wait. A bigger drawer. A bigger drawer. That is so nice. You might hear a clicking sound. The only problem I've got is where this beam back here attaches. I need to just tweak it. It's sitting a little bit high and it's catching on the bracket. This one says 245 degrees. I don't need that high though. I only need 100 degrees. It's just for heating the PCB. Yeah, I don't need to go higher. I'm not going to go higher. Okay, thank you everyone. It's coffee time. I'm going to get another coffee and get to work. Did I use springs? No springs. Just sliding along a 3D print. And it works great. No, I don't want it to pop out itself. I want it to only pop out when I need it. I needed it to work with one finger though, or one hand, right? That's really important. So I'm working and I can just open it with my hand, grab something and close it. Yeah. That one is 120 millimeters. Is it? 120 millimeters. Right, it's only 12 volts though. So it's going to heat really slow. Yeah, not ideal. Cool. Okay, thanks everyone. Appreciate your help today in doing this, and I'll let you know how it goes. Have a nice rest of the week. And sorry about the stuff up at the start of the stream. Catch you later. Bye, everyone.